Glycolysis. Pag sinabi natin glycolysis, glyco means glucose, then lysis means breakdown. So, glucose molecule is split into two 3-carbon pyruvate molecule. So, dito, glucose, 6-carbon compound, at pag nag-breakdown to sa dalawang pyruvate, which is 3-carbon compound, in this conversion, energy release of ATP and NADH. Pyruvate further metabolize in energy pathway that produce more energy. Process ng glycolysis, meron dalawang phases. First phase, the glucose has first converted glucose to glyceraldehyde 3-phosphate. In this phosphate actually uses energy instead of producing it. So dito sa first phase, nagamit ng energy, hindi siya nagproduce, which is sa second phase naman, and second phase, dito nagproduce ng energy. So, punta tayo sa may glycolysis reaction. So, bibig ko the enzyme of glycolysis extracts some of the potential energy stored in glucose. The process yields 2 ATP molecules and 2 electron-carrying NADH molecule. So dito, papakita ko sa inyo yung glucose, kung paano siya na-convert. So glucose converted into glucose 6-phosphate sa tulong ng hexokinase. What is hexokinase? Hexo means 6, then kinase means phosphorylation reaction. Then ATP converted into ADP. Then glucose 6-phosphate converted into fructose 6-phosphate. Ito naman yun. So, dito, na-convert siya sa fructose 6-phosphate sa tulong na phosphofructokinase. So, then ganun din ATP converted into ADP. And after that, fructose 6-phosphate is converted into fructose 1,6-bisphosphate. Okay. So after nun, so fructose 1,6-bisphosphate, merong glyceraldehyde 3-phosphate, then DHAP. All DHAP will be converted into glyceraldehyde 3-phosphate. So ito, ang DHAP ay converted sa glyceraldehyde 3-phosphate sa tulong ni isomerase. Then, bago maging DHAP or glyceraldehyde 3-phosphate, ang fructose 1,6-bisphosphate ay sa tulong naman ni aldolase. Is this aldolase? Or yes, aldolase. Glycolysis requires an input of 2 ATP to activate glucose. The activated glucose is then split into 2 3-carbon molecules. So, ito yung kaninang pinakita ko. Each of 3-carbon molecule proceeds to the energy extraction reaction of glycolysis. Ito yun sa pinakita ko kanina. Then, first 3-carbon molecule is oxidized, producing 2 NADH molecule. Then, each 3-carbon molecule donates its phosphate groups to ADP molecules, producing ATP molecules. So, ito, hindi pa. In total, 4 ATP are produced. Recall that 2 ATP were used to start reaction. The net yield is 2 ATP, which is ito yung naunang dalawang ATP. Note that this reaction do not require oxygen. Glycolysis can therefore occur in anaerobic condition. Glycolysis yields 2 ATP molecules to electron-carrying NADH molecule and 2 pyruvate. Yeah.
Hi, ma'am! We're the last group, and we're here to report cell respiration. So first, what is cell respiration?
Cell respiration is a set of metabolic reactions and processes that takes place in the cell of organisms to convert biochemical energy from nutrients into adenosine triphosphate or ATP. and then release waste products. Yung pyruvate na nabuo sa glycolysis, papasok na siya sa mitochondria. Yung pyruvate, pupunta siya dun sa mitochondrial matrix. Sa mitochondrial matrix,
May enzymes?
meron dong enzyme na kung saan ikakat niya yung 3 carbons, tapos yung pyruvate, magiging 2 carbons fragment na lang, tapos magre-release siya ng carbon dioxide.
So yung natirang dalawang carbon or 2 carbon fragment ay mag-attach sa coenzyme A para makabuo ng acetyl-CoA.
Pyruvate oxidation. Each pyruvate goes into the mitochondrial matrix. It is converted to a 2-carbon molecule bound to acetyl-CoA. Carbon dioxide is released and NADH is generated. Yung pyruvate oxidation, nangyayari siya dun sa mitochondrion. Tapos yung pyruvate na nabuo sa glycolysis ay pupunta dun sa mitochondrial matrix. Tapos sa pyruvate may magbabound na enzyme doon, tapos tatawagin siyang acetyl-CoA. Tapos sa process din na yon, yung may marirelease na carbon dioxide tsaka makabuo ng NADH.
Citric acid cycle or Krebs cycle. Acetyl-CoA combines with a 4-carbon molecule and goes through a cycle of reaction, ultimately generating the 4-carbon starting molecule. ATP, NADH, and FADH2 are produced, and carbon dioxide is released. So sa Krebs cycle, yung acetyl-CoA na galing sa pyruvate oxidation is magkakombine sa existing 4-carbon molecule. So nandun na talaga siya, magkakombine na lang sila. Then, magkakaroon doon ng reaction at ang mapaproduce nun is ATP, NADH, and FADH2. Tapos yung carbon dioxide is released. Oxidative phosphorylation. NADH and FADH2 made in other step deposit their electrons in the ETC or electron transport chain, turning back to NAD plus and FAD plus. As electrons move down the chain, energy is released and used to pump protons out to the matrix, forming a gradient and that. At the end of the ETC, oxygen accepts electrons and takes up proton to form water. So, sa oxidative phosphorylation, dun na-form yung ATP. So, yung mga nagdala ng electrons na NADH and FADH2, nilalagay nila yun sa channel na sa ETC, sa electron transport chain. So, dun lang nag-occur yung process. Sa cell respiration, yung unang process is glycolysis. Sa glycolysis, yung glucose
Yung glycolysis, nag-occur siya sa cytoplasm. Sa glycolysis, meron doon glucose tsaka dalawang ATP. Tapos yung ATP, mag-breakdown siya into ADP. Tapos yung natirang phosphate, mag-attach siya sa glucose. Bali yung isa pang ATP, ganun din yung nangyari. Na-breakdown din into ADP, tapos yung phosphate na-attach dun sa glucose.
So, bali yung glucose, may dalawa na siyang phosphate. Then, may bagong enzyme na mag-breakdown doon into pyruvate.
Glycolysis. Glucose or 6 carbons gets converted into 2 molecules of pyruvate or 3 carbons. ATP is made and NAD plus is reduced to NADH. Sa respiration, meron ng stages. Ang una is glycolysis. Sa glycolysis, meron dong glucose na kung saan binubuo siya ng 6 carbons. Tapos, mahati siya into 2 pyruvate na kung saan isang pyruvate merong 3 carbons. Tapos sa glycolysis din, merong mabubuong ATP, tapos yung NAD plus, mare-reduce siya into NADH. Sa Krebs cycle naman, yung acetyl-CoA, mare-remove sa kanya yung coenzymes. Tapos, matitira na lang yung two carbons. Tapos, meron doon four existing carbons. Tapos, mag-a-attach silang dalawa. Tapos, magkakaroon na ng 6 carbons.
So, yung 6 carbon chain na yun, i-extract sa kanya yung hydrogen, i-extract sa kanya ng NAD plus. So, magiging NADH na siya. Dalawang beses mangyari yun. So, magiging 4 ulit siya. 4 carbon chain. Then, sa huli nun, yung FAD.
Yung FAD naman, mag-extract din siya ng hydrogen. Sa FAD, dalawang hydrogen yung kukunin niya. Pero sa NAD, isang hydrogen lang. Tapos yung sa NAD, pag mag-extract siya ng hydrogen, mababawasan siya ng isang carbon. Kaya
mag-extract siya ng carbon dioxide.
Dun sa huling process na FAD, 4 na carbon yun. Pag nag-extract siya ng dalawang hydrogen, 4 pa rin siyang carbon, hindi siya nabawasan. So, yung 4 existing carbons,
doon siya nanggagaling sa naunang Krebs cycle.
Kaya, kung sa Krebs cycle, meron agad siyang 4 existing carbons. Yung NADH, mag-attach yung electron doon sa complex 1. Tapos sa complex 1, yung chain na yon meron siyang supercharge. Tapos, ipapump niya yung electron doon na kung saan maglalabas ng protons, yung maraming protons. Tapos naman, yung FADH2,
Wait lang. Yung electron na galing sa complex 1, ipapasa niya sa CoQ na nasa ibabaw ng complex 2. Yung CoQ na yun yung parang hintayan lang ng electron ng signal para may pass siya sa ibang channel. Then, yun.
Yung FADH2 naman, nag-attach siya sa complex 3 agad. Kasi yung
Complex 2.
sa complex 2 pala. Yung FADH2, mag-attach siya dun sa complex 2. Yung tatandaan lang yung NADH,
sa complex 1 lang siya na attach na electron. Then, yung FADH2, sa complex 2 lang rin siya nag-attach na electron. Then, yun na. Yung ipasa ng FADH2 na electron sa complex 2, may ipapas naman yun sa CoQ rin. Then, magsama na sila yung electron dun sa CoQ na naghihintay doon. Then, yung electron na yun, may ipapas naman siya sa complex 3. Then, yung mangyayari doon,
yung sa complex 3 naman, meron din siyang supercharge. So, yung electron na nalipat doon, pag magpapump siya ulit, tapos maglalabas ulit siya ng protons. After nun, yung electron na nasa complex 3, lilipat naman siya dun sa cytochrome C.
Yung cytochrome C, siya lang rin yung magpapas ng electron na yon sa complex 4. Then, dahil may supercharge din yung complex 4, magpapump din siya ng maraming protons palabas ng matrix. Then, marami ng protons na nasa labas, diba? Then, i-use naman yun sa ATP synthase para makapagbuo ng ATP, tama ba?
Oo. Mampahabol lang po, yung sa electron transport chain, yung complex 4.
So, kanina may nabanggit kaming dalawa na medyo magulo. Yung CoQ and cytochrome C, sila yung receptor, electronic receptor. So, may panghuli pa. Yung panghuling electronic receptor is oxygen. So, yung complex 4, ipapasa niya yung natitirang electron na galing sa NADH and FADH2 papunta sa oxygen. Then, sa oxygen na yun, yung oxygen na yun is mag-split siya into 2 oxygen ions. Then, yun, magko-combine siya sa hydrogen and magpo-form ng water.
Water or H2O.